Hi guys, welcome to our first lesson of Algebra 2B, and we are just going to do a review on graphing. And so if you'll notice, we have three different types of graphs that we're going to talk about today. Graphing linear equations, graphing absolute value equations, and finally graphing quadratic equations. So you've had all three of these. We're just going to kind of practice some stuff. So when you graph a linear equation, it's going to be in different forms. This form is y equals mx plus b. This is probably the most common form, where m is your slope, and so this is our slope, and b is our y-intercept, so where it crosses the y-axis. So this one's going to cross the y-axis at -2. So I'm going to put my first point there, and then I'm going to go up 1 over 3. So I don't get too caught up in direction. I just know at the end of the day that if it's positive, it's going to look like this. And if it's negative, it's going to look like this. So that helps me kind of get started. So I'll just go up 1. If I go to the left 3, 1, 2, 3, it would give me a negative slope. So I don't want that. So I'm going to go to the right 3, 1, 2, 3, right there. And then I can do it again, up 1 over 1, 2, 3. I can also go the opposite direction. So I'm going to go down, but I'm going to go this way. 1, 2, 3. Down, 1, 2, 3. So it looks like this. Make sure that you connect the dots and you put arrows on both sides because it goes on and on forever. So this form is called standard form, and what's really nice about this is this deals with intercepts. So you could do one of two things. You could either solve for y and put it into slope-intercept form, or you could just take this as it is. So if I forget about the y and just solve for x, so that I have 3x equals 6, divide by 3, x equals 2, this is going to be my x-intercept. So 1, 2. I'm going to do the same thing to find my y-intercept. So I'm going to not worry about my x term because that's all zeroed out when I'm finding the y-intercept. So I have negative y equals 6, so y equals -6. So 1, 2, 3, 4, 5, 6 right here. And then it's just a matter of connecting the dots. So I can still, that looks terrible, sorry. So the reason why we X out the terms we don't want is because when we're trying to find the x-intercept, it's going to be something, our intercept, and then 0. So if I set y equal to 0, that whole term becomes 0. And the same thing for the y-intercept. It's going to cross the axis at 0 and then whatever that y point is. So if I make this x 0, this whole thing becomes 0. So it's a really nice tool to use. I don't think a lot of people use it. And then you can go ahead and like find the slope, rise over run, get the slope, get everything you need. It's just really handy to know. Okay, so I have a couple of, three kind of different things that you'll be shown over, or you have learned over the course of learning linear equations. So notice that there's no y-intercept, so there's no b, and we just have a negative for our slope. So what this means is that our b is 0. So it exists, it just crossed the y-axis at 0. And then our slope is going to be -1. So when you just have a negative, that's implied -1. So we're going to go down 1 over 1. We can also go up 1 into the left 1. Notice I'm creating that negative slope. So it looks like this. Okay, so what if we don't have a slope at all? So what if I just have y equals, this doesn't exist, mx, and then plus b. I know that it hits my y-intercept right here. So we are going to be dealing with either a horizontal line or a vertical line in this case. Well, if I have a vertical line, it doesn't make that 3 specific. It goes through all the points on the y-axis. And we did not learn that. We learned that it has the y-intercept of 3. So it's going to go this way. So what's happening is that the slope exists. It's just the same thing as saying 0m plus 3. So notice you have a 0 slope here. If we have x equals 3, that is going to be a vertical line because it is not in y equals mx plus b form. We can't get it into that form. This is our final form that we're going to talk about, and it's called point slope form. And this is really nice sometimes, depending on like what kind of information you have. So the first thing that this does is it tells us a point. So our point is -1, +3. So I'm going to start there. And then this is our slope. So I'm going to go down 2 over 1, down 2 over 1. I can also go up 2 and to the left 1 so that it creates this. And that is it on linear. So now we are going to transfer over to absolute value. So remember, absolute value looks like either a right side up or an upside down V. Okay, so if you probably learned, this is the generic formula for absolute value equations. So this K, that is going to be the x value of your vertex, and the h is going to be the y value of your vertex. So notice how this is x minus k, so it's going to look opposite. So like for instance, this, my vertex, is going to be -1, -2. So right there. Okay, also my a, that is my slope, just like it was right here, the same concept. And it's not technically a slope, but we can kind of use it like that, and I'll kind of explain why. So an absolute value is 2 lines coming together. So that's where we're going to get that slope from. So if I look at this as 1 over 1, the only difference between this and a line is that we're going in 2 separate directions. So I can go up 1 over 1 in this direction and up 1 over 1 in this direction. So it looks like this. And that's where we're going to get our V from. Okay, if I have a -3 for my slope, I'm going to look at that as -3 over 1. And so it's going to end up like this. So anytime your A is negative, it's going to go down. Anytime your A is positive, it's going to point upwards. So if I have -3 times the absolute value of x plus 1, and there's nothing out here, my vertex is going to be -1, 0. That's going to be my starting point right there. And then I'm going to take that kind of slope, not really, but kind of, I'm going to go down 1, 2, 3, and over 1 to the right and over 1 to the left. And then do the same thing, 1, 2, 3. So it looks like that. And notice how this one is skinnier than this one. So as this number gets bigger, the skinnier it gets. And I don't care about the negative. I'm just talking about like 3, 4, 5, 6, 7. It just keeps getting skinnier and skinnier. If I have like 1/3 or like 1, it would be like 1/8. That's going to keep getting fatter and fatter and fatter, or wider and wider and wider. Okay, so graphing quadratic equations, the formula is very, very, very similar. So we're still going to have an A, and instead of using absolute value bars, we are going to use the squared, so parentheses squared, but it's the same concept that applies. Obviously, we're not going to have a line, so we can't really use slope concept there, but we're going to grab our vertex in the exact same way. So this, my vertex is going to be 3, 1. Over here, now notice that there's nothing in with the parentheses, so it's just going to be 0, 3. Okay, so let's start there. 1, 2, 3, 1. So that is my starting point. I also know, just like this A told me, this A is also going to tell me if it's positive, it goes up. If it's negative, it goes down. So I automatically know that this parabola is going to look like this, and this one is going to go down. Okay, so from here, let's go ahead and make an XY chart. So we have almost everything we need. We just need to kind of finish it up a little bit. So our vertex was 3, 1, and we're going to put that in the middle. We're going to do the same thing over here, and we're going to put that 0, 3 in the middle. Okay, now, as you may have learned, everything on each side of this is going to be symmetric. So let me show you. So I'm going to go up and down from 3. So I have 3, 2, 1. So I have 1, 2, 3, 4, 5. So you are going to use 5 points here. Same thing with over here. So I have -1, -2. So let's start counting down. So -2, -1, 0, 1, 2. So notice that both of these have 5 points. I'm just going to stick these points in my calculator to come up with the y values for them. So what I mean is that when they repeat is my point for 1 is going to be the same y value as my point for 5. My point for 2 is my y value is going to be the same as my point for 4. So go ahead and fill that in and see what you can get. Okay, so once you typed in 1 here, I'll go through this one. So I have 1/2, 1 minus 3 squared plus 1. So 1 minus 3 squared is -2. And so -2 squared, that's 4. Half of 4 is 2. 2 plus 1, 2 plus 1 is 3. So that's where I'm getting that, this one, and then I can automatically fill in this one. So my next thing I'm going to do is just plot the points that I found. Okay, so once you've plotted the points, we are going to connect the dots so that it makes this nice rounded parabola, and notice the arrows on the end. So go ahead and do problem number 9. Okay, so I found my points and I plotted it. So let's go ahead and kind of work with the numbers. So I'll choose 2. So -2 squared plus 3. You do please excuse my dear Aunt Sally. So -4 plus 3 is -1. So that's where I'm getting that -1 from. And that is it.